Hi dear students, last day we discussed about the theorems which we are going to study in this chapter, polynomials, the remainder theorem and the factor theorem. Today we are going to study about the remainder theorem and its application. So as to study the remainder theorem, let me just give you some examples for that one so that very fast you can understand the theorem. Just consider two numbers 15 and 6. Two numbers 15 and 6. Let us divide this 15 by 6. What you will get? When 15 is divided by 6, you can see that 6 2s are 12 and the remainder is 3. That means here you can see 15 is the dividend, 6 is the divisor, and q is the quotient you received, and the remainder is 3, right? So we can write this 15 as 15 is equal to 2 into 6 plus 3, right? 15 is equal to 2 into 6 plus 3. So here you saw the remainder as 3. So one thing which we should note that the remainder is always lesser than the divisor. Here what is the divisor? 6 was the divisor. So as 6 is the divisor, we can see that the remainder came 3. So one thing is very clear, whenever you are dividing any two numbers, you might have noticed that one, the remainder will be always lesser than the divisor, or it can be 0. Clear? Let us consider one more example, 12 and 6. Let us divide 12 by 6. How much you will get? 12 when divided by 6, you know, 6 2s are 12, then the remainder is 0. So here you can write 12 is equal to 2 into 6 plus 0. That means here you can say that the remainder is 0. That means it is perfectly divisible. It is perfect. In this case, you can say that 2 and 6 are the factors of 12. Or in other words, you can say 12 is a multiple of 6 and 2. But what was there in the first case? There the remainder was not 0. So at that time, you cannot say that 6 is a multiple of 15. You cannot say that. It's a factor of 15. You can't say like that. Why? Because the remainder is not equal to 0. But here, as the remainder is 0, we can say that 2 and 6 are the factors of 12, as well as 12 is the multiple of 2 and 6. This thing you have studied in your smaller classes, and you know what is factors and what is the meaning of multiples. But from this one, let us get into this chapter, because here we are dealing with polynomials. Now let us consider a polynomial here. Now we were simply taking two numbers and dividing that one. That's what we have studied in our smaller classes, and you are very familiar with it. But in this chapter, as well as we are studying polynomials, we must have to learn how to divide a polynomial by another polynomial. For that, let me take an example. Here it goes. 2x cube plus x square plus x. It is a polynomial in x. What is the degree of this polynomial? The degree of this polynomial is 3, because the highest power is 3. I simply asked you, okay. So 2x cube plus x square plus x. Here you can see a polynomial. And let us divide this given polynomial by a monomial x. Okay. So for that one, what we will do? 2x cube plus x square plus x divided by x. That means when you are dividing a given polynomial by another monomial or by another polynomial, the main thing which you have to understand is, here you can see there are three terms, right? The first term is 2x cube, the second term is x square, and the third term is x. So here there are three terms, so each term should be divided by x. That's very important, which you have to note. Each term should be divided by x. So we can write 2x cube plus x square plus x is equal to 2x cube by x plus x square by x plus x by x. That is equal to 2x cube by x, means 1x on the denominator and 1x on the numerator will get cancelled, and the remaining will be x square, right? So you will get 2x square plus, what is the second term? Here you can see the second term is x square divided by x. 1x can be cancelled on the top and bottom, so 1x will be remaining on the numerator part. So you will get a x. Third time, x and x on the numerator and denominator, they get cancelled each other, and you will get 1. So here you will get it as 2x square plus x plus 1. This can be written like this: 2x cube plus x square plus x is equal to x into, right, x into 2x square plus x plus 1. That means inside the given polynomial, you can see, if you are analyzing each terms, you can see in every term x is a common. That means you can take out x. That is why it is written x into 2x square plus x plus 1. What does it mean? In the first thing I told you, when we studied the example, 12 is equal to 2 into 6. 12 is equal to 2 into 6. What does it mean? 12 is a multiple of 2 and 6. So in that same way, you can say here x and 2x square plus x plus 1 are the factors of the given polynomial. Or in the other words, you can say 2x cube plus x square plus x is a multiple of 2x square plus x plus 1 and x. Clear? So in this way, you can understand what is the factors. So here you could divide each term by x. Very perfectly you could divide. Let us take one more example so that it will be very much clear for you. Let us go to another example. Consider another polynomial, 3x square plus x plus 1. Again, let us divide by the monomial x itself. So I told you already, you have to divide each term by x. So what is the first term here? It is 3x square. Second term is x. Third term is 1. So 3x square, inside that one x is there. X and x will get cancelled. You know it. I already defined it right now. What is the second term? It is x itself. What is the second term? It is x itself. So x by x, you can cancel x and x. What about the third term? It is 1 by x. 1 by x you can't cancel because one is number, another one is a variable. So here, if you are trying to divide each term by x, the third term remains odd, right? Because you cannot see there any like terms to be cancelled. So that means in the first two terms, you can take x as common. So you can write it as x into, if you're considering the first terms, you can take x into 3x plus 1. Then what about the other term? It will remain as the remainder plus 1. That means that 1 will be an odd one, right? It is an odd one. So we can say if we are dividing 3x square plus x plus 1 by x, the remainder will be 1. And the quotient will be 3x plus 1. So here we can say you got the remainder. You got the remainder. If there is a remainder, then we cannot say something that it is a factor of that one. We can't say it is a multiple of that one, right? We can't say those things because you can see there is a remainder. So this thing should be there in your mind and you can write this same thing. This same thing can be written like this. You know here what is the dividend? The dividend is 3x square plus x plus 1. What about the divisor? The divisor was x. What is the quotient which you received here? The quotient is 3x plus 1. What about the remainder you received? It is 1. So you can write here as, you can express this like this, 3x square plus x plus 1 is equal to x into 3x plus 1 plus 1. Means 3x plus 1 was within brackets, plus 1 is another term. It's another term. That means dividend is equal to divisor into quotient plus remainder. In other words, if we are considering them as p of x and g of x like that, means if p of x is the dividend and if g of x it's the divisor and the quotient which you received is q of x and the remainder which you received is r of x. What does it mean? P of x, q of x, r of x. What is the meaning of that one? Polynomial in x, because right now we are dealing everything with polynomials. So here it is not simple numbers, everything is polynomial. That's why we are considering that p of x, g of x, r of x, q of x like that. So here you can write p of x is equal to g of x into q of x plus r of x. This is very important statement because this is the statement which you are going to study and we are going to discuss in our 10th class first chapter. So this is very important, this statement. So keep this thing in your mind. Whenever the remainder is not equal to 0, we will say it is not a factor. And if the remainder is equal to 0, we will say it is a factor. Keep this in your mind because when we are talking about the factor theorem, there again we will have to discuss about this same thing. It's that much important. So now let us get into a question and let us understand what it is. How to divide a given polynomial by another polynomial. Okay, here goes the first question before you, an example. P of x is equal to x plus 3x square minus 1 and g of x is equal to 1 plus x. That means you have to divide p of x by g of x. The first step which you have to do is make sure that the given polynomials are in the standard form. What does it mean by the standard form? Standard form means you have to arrange the given polynomials in such a way that the powers should be in the descending order. Descending order means decreasing order. It should be in the decreasing order. So here you can see x plus x square minus 1. X, then came x square. It is not in the decreasing order, right? So first of all, you will write the higher one, the bigger power one. So here 3x square is having the highest power, right? So we will write that in the first order. So we will rearrange the items like this. P of x is equal to 3x square plus x minus 1. Now it is in the standard form. What about our g of x? It is 1 plus x. So first of all, you have to write the variable part. Then towards the last only you will have to write the constant part. So here it is 1 plus x. We will just make it into the order, bringing them into the order. We will write it as x plus 1. Is that clear? Now both of them are in the standard form, and now let us go to the division, and this division method is what we call the long division method. So let us go for it. 3x square plus x minus 1, and on the divisor part comes x plus 1. Step number 1. First of all, I told you have to arrange them in the increasing order of their powers. It's over. Now you brought them within the long division method, right? This is the way how we divide it in our smaller classes. Same, but here it's a number in polynomial. It's a polynomial expression is given. That's the only difference. Okay. Now listen to this point. This is very important. The first thing what you have to do means you have to take the first term of the dividend. What is the first term of the dividend here? It is 3x square. Take the first term of the dividend, 3x square, and the first term of the divisor. What is the first term of the divisor? Divisor was x plus 1. So the first term of divisor is x. So choose the first term of the dividend and the first term of the divisor and divide them together. So 3x square divided by x. Taking both of the first terms and dividing them. 3x square divided by x. X and x will get cancelled. 3x you will get, right? And this 3x will be the first term of your quotient. So on the quotient part we will write 3x. Next one. So you got the quotient. You got the first term of the quotient. Now multiply this quotient by the divisor. What is the divisor? X plus 1 is the divisor. Now we are going to multiply this x plus 1 by the first term of the quotient. So x plus 1 into, what is the first term of the quotient? 3x. So 3x into x plus 1. So 3x into x, it is 3x square. We will write them beneath the dividend part. Beneath the dividend part. So 3x square you got it. So 3x square plus, now what is the next term? 3x into 1. 3x into x we wrote 3x square. Then 3x into 1. 1 is the second term of the divisor. 3x into 1 is 3x itself. So we will write 3x. We will draw a line. Now you have to find the difference between them. 3x square and 3x square. When you are subtracting them you will get 0. What's the next term? X and 3x. X minus 3x. What is x minus 3x? X means 1x. 1x minus 3x. It is minus 2x. So you will write minus 2x. Next number you will bring it down. It is minus 1. Okay. Now here you got minus 2x minus 1. Minus 2x minus 1. And this one, minus 2x minus 1. This is the next dividend. We are going to consider this again as a dividend. This will be the second dividend. And forget not, now you got this one. Now again we are going to repeat the same process. Take the first term of the dividend, take the first term of the divisor, divide them together. Here the first term of the dividend is minus 2x. First term of the divisor is x. Minus 2x divided by x. X and x will get cancelled, minus 2. And that will be the second term of your quotient. First term already you received it. Now the second term of the quotient. Now minus 2 on the place of quotient. Clear? Now you got minus 2. Now you got minus 2. After this one, what you have to do? You have to multiply this quotient, means what you receive right now, the second term of the quotient, by the divisor. The divisor is x plus 1. So minus 2 into x plus 1. Minus 2 into x, it is minus 2x. Minus 2 into plus 1, it is minus 2. So again you will get minus 2x minus 2. Draw a line. Again you will have to subtract them. While subtracting, the first term they will get cancelled. That means minus 2x, it is 0 itself. What is the second term? Minus 1 minus 2. Minus 1 minus 2. Minus 1 minus 2. Whenever you are subtracting two terms, forget not, you have to change the sign of the second term. Change the sign of the second term, then add them together. That's the process. Here minus 1 is the first term, beneath minus 2 is there. So changing the sign of minus 2, what it will become? It will become plus 2, right? Automatically it will become plus 2. Keep that name, there is no need to write there. It is plus 2. So minus 1 plus 2. Minus 1 plus 2. Now you have to add them. Minus 1 plus 2. When you are adding different signs, how you will add them? First of all, find the difference and give the sign of the greater number. Here the difference of 1 and 2 is 1. So the remainder will become 1. And the bigger number here is 2. And the sign of 2 is plus. We imagined as plus, right? So the sign of 2 is plus. That's why plus 1. If it is plus 1, there is no need to write plus there. Simply you can write it as 1. So here we can say that what is the dividend? The dividend is 3x square plus x minus 1. What was the divisor? It is x plus 1. What is the quotient which you received? It is 3x minus 2. What is the remainder? It is 1. So here you can write this as 3x square plus x minus 1 is equal to x plus 1 into x plus 1 within brackets, x plus 1 into another bracket we will write 3x minus 2. X plus 1 into 3x minus 2 plus remainder 1, right? Plus 1. That means dividend is equal to divisor into quotient plus remainder. That is the way. So we can represent this as p of x is equal to g of x into q of x plus r of x, where p of x is the dividend, g of x is the divisor, q of x is the quotient, r of x is the remainder. And from this one, see, right now we have to divide like this so as to find the remainder, right? Whenever you are dividing, then only you will find the remainder. We done it right now. In whatever case, if I am giving you 99 divided by 7, you will have to divide them and then you will get a remainder. But without dividing, if it was number, it was easy to divide, right? But in these cases, it's not that much easy to simply write these numbers and taking the first term of the dividend divided by the first term of the divisor, then multiplying that with the quotient and then bringing it down. It's totally going to mesh, some of them. So it's a long division method. That's why it is, this name of this method is also termed as long division method. So there is another thing which makes this much more simpler. That is the topic actually which we are going to discuss today, the remainder theorem. The remainder theorem states that let p of x be any polynomial of degree greater than or equal to 1, and let small letter a, let a be any real number. That means there is a polynomial p of x which is having at least a degree of 1 or more than 1, and you are considering another letter, small letter a, another polynomial a. If p of x is divided by a linear polynomial x minus a, then the remainder is p of a. In the last class we discussed how to find p of 1, p of 2, p of 3, p of 4, like that. In simple ways I will say, if a polynomial is given in front of you, right now we got a polynomial, we took a polynomial, what was it? P of x is equal to 3x square plus x minus 1. We were dividing it by another polynomial. What was that polynomial? It was x plus 1. And by the long division method, you got as the remainder as 1. By calculating the long division, you could understand the remainder is 0. Is 1. The remainder is 1, not 0. So without long division, how can you calculate the remainder? That's what we are going to discuss. So here you can see the given polynomial is divided by x plus 1. And the remainder theorem says that if you want to check the remainder of this one, when this given polynomial p of x is divided by g of x, what is the remainder which you are going to obtain? If you want to find, there is no need to do this whole long division. Instead, you just take like this, take x plus 1. That is the g of x part, right? X plus 1. Find the 0 of x plus 1. What is the 0 of x plus 1? X plus 1 is equal to 0. That means x is equal to minus 1. Right? X plus 1 is equal to 0. X is equal to minus 1. And p of minus 1, p of this minus 1 will be the remainder of the polynomial. That means there is no need to do the whole long division. Simply find p of minus 1. Inside the given p of x, find p of minus 1. And in this question, you can understand that p of minus 1 will be 1 itself. Very easily you can get. That is the power of remainder theorem. So this remainder theorem is used to simplify the steps. Means without doing long division, you will get the answer. And we are going to study this one in the next upcoming exercise. So in the next class, we will be discussing about that one in exercise number 2.3. There we will be using the remainder theorem in a vast area. That's all for today. Thanks for watching the video. Hope you understood the topics. See you in the next class. Till then, take care and goodbye.